All right, let's look at the homework 11.10, problem number 3. All right, so we have a function f of x equals 5 over x, and we want the Taylor series centered at -3. Right, so let's do that. All right, so here we have f of x is 5 over x, and which derivative. All right, so derivative is going to be, let's see, so 1 over x is x to the -1. So we put -1 in front and then subtract 1 from the power. So it's going to be a -2 power, which is x squared on the bottom. All right, and another derivative. All right, so it's going to be -2 in front. So -1 was already here. So -1 times -2 is +2. And then it's going to be cubed. It's a -3. All right, and another derivative. So it's going to be -6, and then raise it to the 4th power. All right, then it's going to be, let's see, 4 times 6, 24, and then raise it to the 5th power. All right, so let's submit. All right, looks like we got part 1 correctly. All right, so let's move on to part 2. All right, so what we want to do is we want to, let's see, plug in x equals or a equals -3. All right, so this is the original function. So original function is here. If you put -3, so it's going to be -1 here. All right, and first derivative. So if you plug in -3, then you have 3 squared, so negative's gone. And then you still have -1 there on top, so we have -1. All right, the next one is 3 cubed, and then this should be a negative sign there, because -3 cubed is going to be -27. And then you have a 2 on top, so it's a -2. All right, and the third derivative, so if you plug in -3, 3 to the 4th, so we have -6 originally there. And then last one, and to the 5th power, and 24, so it's going to be -24. All right, so let's submit. All right, looks like we got part 2 correctly as well. All right, let's move on to part 3. All right, so these guys determine the coefficient. So you have, let's see, -5 over 3, that's for the constant term. All right, then the linear term, so it says the -5 over 9. So maybe I'll put it this way. So it's going to be negative, seems like. And then you have a 5 is over there, and over, and that's 3 squared. How about that? All right, then the next one, square term. So it's going to be negative. All right, and it's going to be 5 times 2. Then I'm going to go over 3 cubed. All right, and maybe I'll keep the same format here. So here I'm gonna put let's see, 5 here. All right, then put maybe times, and then here's 1. All right, then we have that, and we still have -5 and times. All right, so you have 6 over 3 to the 4th power. All right, and then last one is -5 times, and 24 over 3 to the 5th power. All right, so let's submit. All right, actually I messed it up, sorry. I forgot to put the n factorial on the bottom. All right, so the first one is over 1 factorial, so that was okay. But for this one, I would have to put, let's see, on the bottom. So you would have to put 2 factorial, right? And then here, I would have to put times 3 factorial, right? Then here, I would have to put the 4 factorial on the bottom. All right, but before we submit, then we notice that here 2 and 2 factorial is going to be actually 1. So because 2 and 2 factorial cancel out, so you get that. All right, and the 6 and the 3 factorials are the same, so I'm going to put 1 here and get rid of that. All right, so it looks like this is going to be simplified quite a bit. So we can put 5 on top. All right, so we have a 5 on top. I'm just trying to simplify it as much as possible. All right, so here's a 5 on top. And right, and here is 24. 24 and the full factorial are actually the same. So we can cancel that, and I'm going to put 5 instead, and so that I can get rid of that. And the full factorial cancel with 24. All right, so let's submit, and hopefully this will. All right, looks like we got part 3 correctly. All right, let's do the final part 4. So we got a formula. So it looks like -5 is always there. So it's a -5, and then divided by, and so let's see. First power is going to be 2, and second power is going to be 3. So it's going to be always 3 to the n plus 1 power. Right? Then you have quantity x plus 3. Because it's a Taylor series centered at the -3, and then raise it to the n, of course. All right, I think that will do it. Let's submit. All right, looks like we got the part 4 correctly. All right, that's it. I hope that this was clear.